Cordless, bagless stick vacs have become the go-to vacuum for people who want convenience. They take up less space, they're lightweight and portable, and you don't have to buy and change out dirt bags. That alone is a big selling point. But there's one area where bagless vacuums fall short in a big way, and that might have you reconsidering your grandma's bagged vacuum. Let's get the elephant in the room out of the way. Bagless vacuums release a ton of dust right back into the air whenever you empty them. We tested over 15 different vacuums, including bagged and bagless models, corded and cordless, expensive and cheap, and not a single one of our bagless vacuums kept dust from flying right back into the air when being emptied. Since you have to open the dust bin to let the dust out, lighter dust and particles get pulled up through air currents and end up right back where you don't want them. Of course, there are ways to reduce the amount of dust that gets loose. If you prefer the convenience of a bagless vacuum, we recommend emptying it outside if possible. Or you can wrap the body inside a garbage bag before opening the dustbin to trap as much dust as possible. But there's no replacement for a bag specifically designed to keep dust and debris contained. Compared to the simplicity of pulling out a dirt bag and tossing it wholesale into the trash, there's really no competition here. Things start to get more interesting, however, when we look at particle filtration during use. You may think that bagged models have the advantage there too, but what we found might surprise you. To test the air quality of different vacuums during operation, we needed the right testing environment. At first, we tried simply testing in one of our test rooms, but the particles weren't concentrated enough for our sensors to pick up meaningful measurements. So we had to think outside the box, or rather, inside the box. In the end, we built our very own sealed acrylic test chamber. The chamber keeps the dust concentrated at measurable levels. The two particle sensors inside the box let us measure both PM10 and finer PM2.5 particles. And to keep things on an even playing field, we vacuumed the same weight of standardized filter test powder for each vacuum. Since the test powder is hazardous to inhale, our testers, or anyone setting foot inside the room during the test, has to take the utmost safety precautions. We also clean the air inside using an air purifier before and after each test and give the box a good wipe down. After testing our initial batch of vacuums, we found that cheap bagless models with minimal or inadequate filters had the worst particle filtration performance. Bagged vacuums tended to perform well, but surprisingly, our top performers were actually bagless models. So what unites these top performers? Well, it all comes down to filtration. Regardless of what kind of vacuum you choose, the post-motor filter is incredibly important. It's the last line of defense between your home and whatever particles do make it past your vacuum's bag or cyclone. This is really where HEPA filters can make a big difference. For a filter to get the HEPA label, it needs to filter at least 99.97% of particles that are 0.3 micrometers in size, otherwise known as the most penetrating particle size. Ominous as it is, the name is pretty self-explanatory. These are the most difficult particles to filter. Looking back at our initial results, the best vacuums feature multiple filtration stages with HEPA-compliant filters. In the case of these older Dyson models, while they aren't officially marketed as HEPA filters, they claim to filter 99.99% of 0.3 micron particles. So they not only meet HEPA specification, they actually exceed it. Either way, the end result is the same. All of these top-performing vacuums are extremely efficient at filtering fine particles. Looking at bagless models, a vacuum like the Shark Performance Plus Liftaway UV900, for example, significantly outperforms a HEPA-less model like the Ryobi 18V 1 Plus. But this also applies to bagged vacuums. The ones that claim HEPA certification significantly outperform those that don't. The bag itself is a big factor here, since it plays an important part in the vacuum's total filter system. In addition to what kind of pre- and post-motor filters it has, the material and construction of the bag can make a huge difference. The Kenmore Intuition Bagged, for instance, was the best performing bagged model in our first test batch. It features a HEPA-rated post-motor filter and uses bags made of a non-woven polymer fabric that also meet HEPA-level filtering requirements. The result? Virtually non-detectable levels of dust during operation. Compare that to the Eureka Mighty Mite. This vacuum lacks a post-motor filter entirely, and its default bags are thin and poorly constructed, allowing a lot of fine particles to escape. So if not all bags are created equal, how much of a difference does your choice of bag really make? To test that, we created a mini-me version of our testing chamber so we could test different bags in isolation. The nozzle dispenses 8 micrometer droplets of a 0.4% sodium chloride solution. As the water is sucked into the first chamber, the water evaporates, leaving only the airborne particles of sodium chloride. They pass through the bag, and 2 PM sensors measure the concentration of particles in the last chamber. To generate the airflow, we used a Miele Complete C3 running on low. As we can see, there's variation even among bags from the same brand. The Miele GN bags, for its air clean system, do a much better job of filtering particles than the newer TU bags in the high clean system. Third-party bags for Miele vacuums, on the other hand, perform notably worse. Meanwhile, the poorly performing Eureka Mighty Mite benefits significantly from using third-party HEPA-rated bags over the standard brand name ones. In most cases, you're better off sticking to the manufacturer's bags and filters, but in some cases, like with the Mighty Mite, the standard bags just aren't very good, so going for a HEPA-rated option can make a big difference. And to really see how much filtering power a bag can have, we decided to run a little experiment and Frankenstein a bag into a bagless vacuum. The Bissell PowerForce Helix is one of the worst vacuums we've tested for filtration so far, the perfect subject. We took the cyclone part out of the dustbin. We then added a hose to move the debris intake to the bottom of the bin, where we attached a bag borrowed from a RoboVac dock. Finally, we took out the foam filter, leaving the bag as the sole defense against particle emissions. Before we get to the results of our experiment, if you want to support us in our quest to mishmash even more vacuums together in the name of science, be sure to subscribe. It helps. Okay, moving on. Shockingly, even without a foam filter, our bagged monstrosity performed about 4 times better than the Bissell in its natural state. Bagged vacuums aren't inherently better than bagless models, but they tend to fall within a narrower range of performance than bagless vacuums, which run the gamut from exceptional to exceptionally terrible. That's because bags offer an extra layer of filtration. The bag itself acts as one big extra filter, trapping dust and debris more effectively than the cyclone on a bagless model can, especially fine particles. Bottom line, if air quality matters to you, the most important thing to look at when buying a vacuum is how good its filtration is. Regardless of whether you prefer the convenience of a cordless, bagless vacuum or the ease of cleaning and maintenance that comes with a bagged model, you should get a model with HEPA filters or equivalent. While a good vacuum filter doesn't necessarily need to be HEPA rated, a HEPA rated filter ensures it'll be high quality. We'll continue to test the air quality performance of vacuums going forward, so you can figure out which vacuum is the best for your needs. Do you have a bagged vacuum, bagless vacuum, and if you use both, which one do you prefer? Sound off in the comments. Until next time, I'm Ben from Ratings.com. Thanks for watching.